Okay, we're going to take a closer look at what this atomic mass is. Remember that is the number, the bottom number on the block of the element on the periodic table. It is the number that is a decimal. Usually many of them are out to many places, decimal places. And we're going to talk a little bit about how we get that atomic mass. We base our measurements of the mass of atoms on the carbon atom. Carbon is a very important atom to us here on Earth, to life on Earth. All living things contain carbon, and so we use carbon as the basis for measurement of atoms' masses. And so we say that 1/12, which would become a little more apparent as to why we use 1/12, hopefully, as we talk about this, but 1/12 of the mass of a carbon atom is equal to 1 atomic mass unit, which is an AMU. And that's how all of our masses of atoms are determined. That's what they're based on. All right, let's talk a little bit. You guys are supposed to know by now the masses of the various subatomic particles. All right, which ones have mass? Which subatomic particles have mass? We have protons, neutrons, electrons. Which ones have mass? If you said protons and neutrons, you were correct. Okay? What is the mass of an electron? If you said 0, you are correct. Protons and neutrons are the only thing in the atom that give us the mass, that give us masses of atoms, because they're the only things with mass. So, when we have atoms that have the same number of protons in their nucleus, but different numbers of neutrons, we call those isotopes. Let me give you an example. C12 and C14 are both isotopes of carbon. C12 has a mass number of 12. C14 has a mass number of 14. So, if the mass of C12 is 12, how many neutrons are contained in the nucleus of a carbon-12 isotope? If you said 6 neutrons in carbon-12, good job. You are right. We know that if this has a mass, if carbon has a mass of 12, that 6 of that has to be due to protons, because carbon has 6 protons. All right? If it has a total mass of 12, that must mean that there are 6 neutrons, because we know that there are 6 protons, which make up 6 of the 12. The rest of it has to be neutrons. So it makes a total of 12. So with that example, next question. How many neutrons are contained in the nucleus of a carbon-14 atom? If you said 8 neutrons, good job. Because again, with carbon, there are 6 protons in the nucleus. So 6 of this 14 is due to protons, 6 protons. What does that leave? Well, 14 minus 6 is 8. That leaves 8 mass particles to be donated by neutrons. So carbon-14 has to have 8 neutrons. And that brings us to this discussion of what is mass number. Well, mass number then is the number of protons plus the number of neutrons. Again, those two particles are the only ones that add mass to our atom. So mass number is the number of protons plus the number of neutrons. So using this little equation, if we take the mass number and we subtract the atomic number, the whole number at the top of the block of the periodic table, that will give us the number of neutrons. That's just what we did with our carbon. We had carbon-12. We took the mass number, which was 12. We subtracted the atomic number, which was 6, and that gave us 6 neutrons. Same for carbon-14. We took the mass number, which is 14, subtracted the atomic number, which is still 6, because we're still dealing with carbon, and that gave us a number of neutrons, which is 8. All right. Many different isotopes of many elements exist on Earth. That average atomic mass is the average mass of all of those naturally occurring isotopes. So they take all of these isotopes that exist and they take the average mass of all of them to find the bottom number there, that average atomic mass. They're all based on the different isotopes of each element.